Hello. Okay, so today we're going to focus on putting all of the transformations together. And additionally, we're going to look at how to graph quadratic relations from vertex form. So let's start with vertex form. Vertex form looks like this. Okay. For the longest time, we didn't really understand the significance of the a value, okay? And we talked about that in 5.1. So the first thing we do when we're looking at the a value is trying to decide whether or not there has been a reflection in the x-axis, okay? So we've been exploring reflections since Unit 3. Now we are making a point of actually articulating that when we are describing the transformations. So if the a value is negative, there has been a reflection in the x-axis, the parabola opens down. If the a value is positive, the parabola opens up, there was no reflection. Then we talked about distinguishing whether or not there had been a vertical stretch, okay, or a vertical compression. Okay, so I like to use the number lines here to explain this. A vertical stretch occurs when the a value lies here, so greater than 1 or less than -1. Okay, over here, this would just be a vertical stretch, whereas over here, first there would have been a reflection and then a vertical stretch. The further away you get from 0, the more narrow the parabola becomes. A vertical compression, and I'm going to replicate that same, number line, occurs in here, in which case we would say there's a vertical compression by a factor of 1/2, 2/3, 1/7, and the parabola becomes more wide. The closer we get to 0, the more wide the parabola becomes. This is all lesson 5.1. Okay. Then we talked in 5.2 about a horizontal translation. And again, when you are in the brackets, you're being lied to. So it's kind of the opposite of what you would think. And in this case, all we're doing is sliding the parabola left or right. We are not altering the direction of the opening, nor are we altering the shape of the parabola. Last but not least, we are looking at a vertical translation. And what you see is what you get. If this number is +2, we slide the parabola 2 units up. If it's -5, we slide the parabola 5 units down. Okay, these are all 4 of the transformations. And let me just add that. And this is the order that we would try to identify them if we had to describe them given an equation. Okay, I will be coming back to this shortly. So I just want to do this and do this, okay? And I will explain what that means when we review how to graph these guys. Okay. So first, I just want to practice going both ways. I want to practice describing transformations given an equation, and I want to practice producing an equation given the description of the transformations. So, for example, if I was given a question like that, okay, first thing I would do is say there has been a reflection in the x-axis. Okay. Maybe I'll try to color code this. Then I would say there has been a vertical stretch by a factor of 2. BAFO is a completely acceptable short form, okay? Then I would say there has been a horizontal translation 4 units to the left. Remember, when you're in the brackets, you're being lied to. It's the opposite of what you would expect. And finally, I would say that there was a vertical translation 7 units down. Okay, now let's talk about what this is going to look like. We know that every graph starts looking like this. Okay, that's the graph of y equals x squared. This guy got reflected, got stretched, so it's now opening down. it got more narrow, and we moved it. The vertex was originally on 0, 0. Now the vertex, I need a new marker. Oh dear. Now the vertex lies on, let's go with red. Now the vertex lies on -4, because remember, it's the opposite of what you would think. It got translated 4 units to the left and 7 units down. So this new guy kind of looks like that, okay? But kind of looks like that, I really don't think is good enough. So after we go through a few more examples, I'm going to show you how to precisely draw these graphs, because I have had students ask about that, but I want to do a couple more examples first. So I think we're going to stick with the red here. I like the red. Let's say I had this. Okay. So we start. This is not negative, so there has been no reflection. 2/5 is definitely in between -1 and 1, with the exception of 0. We don't count 0. So I would say vertical compression by a factor of 2/5. Okay. This tells me that there was a horizontal translation, 1 unit left. Again, when you're in the brackets, you're being lied to. And even though this wasn't here, I'm going to add it just for those of you that are visual and like to see it there. This means this parabola did not move up or down. So there were only 2 transformations applied to the graph of y equals squared. Because as we said before, every parabola starts out here, and then we alter the shape, the direction of the opening, and the location of the vertex, depending on what we see going there. Okay? So again, if I wanted to just sketch what this looks like, this is how every parabola starts. This guy, okay, the vertex is at -1. We didn't move it up and we didn't move it down. We did make it more wide because it was compressed. Okay, so that's just a sketch to get an idea of what it looks like, but absolutely not accurate. And so now I want to move on, and I think I'm going to do that in a new video to show you exactly how you would graph these, and you will continue to use this method in grade 11. So I think it's really important that you learn how to do it well now. And actually, before I shut her down, I just realized I wanted to do a few more examples with you, so hold tight. Let's say I said there had been a reflection in the x-axis, a vertical compression by a factor of 10/11, a horizontal translation 3 units to the left, and a vertical translation 9 units down. Okay, so now we're kind of going backwards. I'm giving you the transformations and you give me the equation. So this is the vertex form of a quadratic relation. Now we just have to make sure we fill these in the appropriate places. So again, I'll try to kind of keep it color-coded here. Just going to get set up. Okay, so now I can fill in my A, my H, and my K. And if you have friends from last semester who remember me saying this, I'd say, okay, once we identify what these values are, we have to fill in our AC, our A, our H, and our K. Whereas when we were doing factored form, we would fill in our R's, our A, our R, our S, okay? It's very late, and so if this sounds ridiculous, I apologize. Okay, so the fact that there was a reflection in the x-axis means this guy needs to be negative. Done. The fact that there was a vertical compression by a factor of 10/11 means this needs to be 10/11. Awesome. The fact that it was horizontally translated 3 units to the left. Remember, we're putting this in a bracket, so it's like we're being lied to. I'm going to make that a +3, even though my instinct tells me it should be -3. And last but not least, the fact that, what color did I not use yet? Red. The fact that this guy was vertically translated 9 units down means that's -9. Okay, some commonly made mistakes I see students do is they forget this guy. This guy's so important, otherwise it's not quadratic. Okay, let's do another one of these just because it's fun. Oh, I moved my camera. Okay. Oh, I don't like that. Okay, here we go. So let's say I just said that there was a vertical stretch by a factor of 4 and a vertical translation 6 units down. Okay, again, every quadratic relation in vertex form follows this format. Now we just need to make sure we fill these in the right spots. So, okay, I'm going to have to fill in my A, my H, and my K. The fact that it wasn't reflected means that's not going to be negative, no problem. A vertical stretch by a factor of 4 means a 4 goes right there. Cool. Now, this quadratic relation was not translated left or right. There was no horizontal translation, so nothing goes in here. Okay, sorry, I should be color coding this. Nothing goes in here. So you can do that, but in all honesty, that's redundant. Okay, so I would try to stay away from doing that, and I'll show you what it should look like in a minute. And then 6 units down, okay? And so we would actually write this out like that, okay? So if there is no bracket in vertex form, that means that quadratic relation was not translated horizontally, okay? This guy, right, every quadratic relation starts looking like that. That's the graph of y equals x squared. This guy got moved 6 units down and got stretched. Okay, is this red graph accurate? No. That's why I'm going to create another video to show you how to accurately produce these graphs.